Hello and welcome to 5-Minute Math. Today we are looking at the 6th grade concept of summarizing categorical data. This is standard 6.12D in the great state of Texas, and we are using item number 37 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. So we have a percentage bar graph here, but it's already made for us. And so let's just go ahead and label each of these categories. And it's going to look just like a regular bar graph. So we've got 45% in category 1. Let's look at 15% in category 2. Category 3, we've got 30%. And let's see, category 4 is 10%. The one difference about a percentage bar graph, even though it might look like a regular bar graph here, is that they always add up to 100. If you go from 0 to 100. Because 100% is going to be complete or full, and so we always use that in a percentage bar graph. But if you add all of these up, you'll see that we've got 5, and that's another 5, that's 100. So that's just one neat little feature about a percentage bar graph. All we need to do, though, is we need to find one statement about the employees that is supported by the data in the bar graph. So one of these statements is going to be correct. 3 of these are going to be incorrect. So let's take a look at this. More than half the employees are in category 1. Well, that's why it's good to know about a percentage bar graph. So remember, percentage bar graph only goes up to 100, which means more than half would need to be 51 or greater. So something greater than 51, because even if you just got 50, that would be equal to half. Well, obviously category 1, it's only got 45. So it is not greater. That does not work for us, so A is not going to be our answer. It needs to be at least 51%. B, the number of employees in category 2 is twice the number of employees in category 3. Well, that doesn't make sense for 2 reasons. First, it just doesn't look correct. Category 2 is not even as large as category 3, but then secondly, the numbers simply don't work out. Now, here's the trick, though. If they were to flip this, look at this. If they were to make this category 3, and make this category 2, now you've got something. The number of employees in category 3, that's 30, is twice the number of employees in category 2, which is 15. So they actually had the right idea. They just gave you the reverse order of the category. So that is not going to work, but I can see how many students might choose this as their incorrect answer, simply because it, on first glance, absolutely, yeah, 15, 30, yeah, 30 is twice as big. Make sure you read the category labels really closely, because that is incorrect. C, the number of employees in category 2 or 3 is greater than the employees in category 1. Now that is kind of tricky, so it has to be one or the other. But even, so that doesn't make sense because neither of them are larger than category 1. But what if you were to replace this with and? If you were to say category 2 and 3, well, guess what? That would be 30 plus 15. That would get you 45. But that even 45 is not greater than 45. It's equal to 45. So that is not the correct answer. So let us hope the answer is D. The number of employees in category 1 is 3 times the number of employees in category 2. So let's just put that into an equation. The number of employees in category 1, 45, is, so there's my equal, 3 times the number of employees in category 2, which happens to be 15. So what is 3 times 15? Well, 3 times 15 is 45. And 45 equals 45, so my answer is D.